Hello guys, good morning. I hope you are doing well. It is another wonderful day, another great day that the Lord has made for us. So, without wasting much time, let us start our class. Now, from the previous class, we left it at a place where we were supposed to discuss other relevant. That one was other relevant and important. Other relevant and important concepts that are also highly tested in exam. That are also highly tested in exam. That is under this same topic, which is approximation and errors. So what are those concepts? Concept number one, use of the word exact. I know you may come across such term, use of the word exact. They are really very much useful. Number two, use of the word nearest. Use of the word nearest. Use of the word nearest or maybe to the nearest. It still refers to the same thing. Then the last is use of inequality sign. Use of inequality sign. Use of inequality sign. Inequality sign. So let's start with the number one. Use of the word exact. Use of the word exact. Now listen. If a value, for example, the width of a rectangle has been stated as exact, but its length is an approximation, we should neither find the maximum value nor the minimum value of the number stated exact. Listen. If, for example, the width of a rectangle has been stated exact, or maybe just any measurement, any value has been stated exact when it comes to this topic of approximation and errors. When any value has been stated as exact, then neither should you find the maximum value nor the minimum value of that particular number stated as exact. Let us look at one example, then proceed on. You may have some question, kindly drop them in the comment section. I'll check, I'll answer you all. Now, check at this example. The width of a rectangle is exactly 60 centimeter. The width of a rectangle is exactly 60 centimeter, but its length is 65 centimeter. Calculate the absolute error in getting its area. These are the type of the question you'll be coming across with. An examiner will not just give you a direct question that here is a multiplication, here is an addition. Like, an examiner will use that kind of format of a question that you have to sometimes think that when it comes to area, we have to do what? We have to multiply. When it comes to volume, still we have to multiply. When it comes to getting time, distance, speed, we have to divide. So an examiner will state your mind, like you have to be in a position to understand these terms. So how do I solve the question? Remember, there's a certain procedure of arranging work which I gave you. So at the middle, I have the actual, the far end maximum, and also the other far end minimum. Then just have it on a table. Now, what is our actual? Listen. But before I fill up the values, let me have a little sketch here of a rectangle. And let me repeat the question. The width of a rectangle, width. What is width? Width is the ni urefu. So width, which is 60 centimeter, and then we have the length, which is 65 centimeter. Length ni upana, if I'm not wrong. Now, having that, this one is exact. But the examiner doesn't tell us whether the length, which is 65 centimeter, is either exact or an approximation. Now, in such cases which an examiner doesn't specify, like this one, this 65 centimeter is not exact or maybe approximation, it is normally an assumption that 65 centimeter is an approximation. You only deal with what the examiner has stated as exact. Now, remember I told you, so we have our actual 60 together with what? Together with a 65. Now, remember it is 60 that the examiner has told us that it is exact. And I've told you that when the word or the value has been stated as exact, we do not get its maximum nor the minimum. The value remains constant. It remains the same in both maximum and minimum column. So here we shall maintain the number 60. So that means a value which is exact does not have an accuracy. A value which is exact does not have an accuracy. Now let us continue. How about 65 centimeters? 65 centimeter has an accuracy of what, guys? Of 1. So you take that one, you multiply it by a half. You get what? 0.5. Now it is this 0.5 that you add to get maximum, subtract to get minimum. So adding it, we are having 65.5. Subtracting it, we are getting 64.95. 64.95. Now, when you're getting an area of something, we deal with the what? Okay, specifically when getting area of rectangle, we deal with multiplication. So in short, we're gonna multiply, and with multiplication, you just do it directly the way they are. Now, having 60 multiplied by 65.5 in your calculator, in my calculator, I'm getting 39. 30. Having 60 by 65 in my calculator, I'm getting 3900. Having 60 by 64.9 in my calculator, I'm getting 3897. 3897, guys. Now, having that, we can now get the absolute error. The only problem was this thing stated exact. And that is why I told you in this topic, when it comes to getting absolute error, you must try very hard to get the correct answer. Because without the absolute error, even getting the relative error, the percentage error, those will not be easy for you. You will just get 0. Now, being that we have this, we can now get our absolute error. And by the way, you might be wondering, why are we not tackling relative error? Why are we not getting relative error? Why are we not getting percentage error? The main reason is, at the start, I told you that getting an absolute error is the only issue when it comes to this topic. Having relative error, I mean having absolute error, it is easy to get relative error. It is easy to get percentage error because those things are just formula that you are applying there. Because having actual value is not a big deal. Having relative error after getting your absolute error is not a big deal. So let's continue. Absolute error is 3930. That is the maximum minus minimum 3897 divide by 2. So dividing this, I shall get my answer at 16.5. Now, this is where most students do mess a lot. You are leaving your answer at 16.5. Okay, some examiners will give you the mark. Yes, it's true you are having the correct answer. But what did the question specifically required us to get? The absolute error in getting its area. In getting its area. And the units have been given in the measurement. The measurement of length, width, they have the unit, which was what? Centimeter. So instead of having 16.5, because some strict examiner may not give you the all 3 marks. And this is where now the competition begins. You find position 1 just missing a little, and Ashisha chini. So having 16.5 is not right. To make it right, you must include the unit. So 16.5 square centimeter. If the units were not given, then your answer would have been 16.5 square. 16.5 square units. You just write the unit because the unit can be kilometer, hectometer, meter, decimeter, centimeter. Any unit would have been there. So I told you it is you to do more research, do more examples. Where there's a problem, you can have it, then we discuss. You can share it through the comment section, then together we shall discuss. Number 2, let us look at concept number 2. Let us look at concept number 2. Use of the word to the nearest. Use of the word. Use of the word to the nearest. Use of the word to the nearest. To the nearest, or maybe just nearest, but it's always nearest. Now listen. This part is very delicate, and most examiners will like a lot to test the capacity of various students when it comes to this topic using the concept or the term nearest. So make sure you understand these things. You see, when examiner just speak on something, he or she doesn't just speak on it like you want you guys to do an exam. No, there's always something being tested in you. Okay. Now, listen. Occasionally, what does the term occasionally first? That's why I tell some of you that love English and mathematics will be just something that I don't know how to describe. You see, the words used in mathematics all are in English. So if you hate mathematics, like unapenda Kiswahili, let me use that term, unapenda Kiswahili. Nowhere in any paper of mathematics you come across will be in Kiswahili. Hautawahi patana nayo. You must love English. kama unataka kufanya vizuri kwa hesabu. But I'm sorry if I may have offended someone because maybe you could be loving Kiswahili. I'm not saying that Kiswahili is bad, but I'm just trying to advise that with mathematics goes hand in hand with English. But I'm sorry kama nimevuka mipaka. All right. When the word to the nearest is used, when the word to the nearest is used, it always acts as accuracy. I hope up to this point where we are, guys, you are in a position to know that, oh, I'm understanding this guy. The term accuracy is talking about, I know, I understand what the term accuracy is. Now, what was I saying? Now, yeah. When the word to the nearest is used, it always acts as accuracy. Whereas for you being examined, wewe mwenye unatainiwa, you only need to divide it by 2, the way we've been doing, to get absolute error, to add or subtract, that will enable you to get the maximum value or the minimum value. What am I saying? Najaribu kusema kwamba the word nearest, when it is used, it acts as accuracy. It is no longer a number. It is no longer a number like what we've been doing all along. Like you get a number, you get its accuracy, then divide by 2 to get the absolute error. No. When the word to the nearest has been used, that particular nearest thing, that particular nearest number, that one is an accuracy. Okay. Normally, when the word to the nearest is used, its unit normally differ with the unit of the other measurement. What am I saying? That the units of the word to the nearest will always differ from the units of the other measurements given in the particular question. We shall look at example for you to understand fully. Don't worry, just listen. Now, so as a student, you must convert to the nearest to the same unit. You must convert that to the nearest to the same unit and later divide it by 2 to get the absolute error. So let us look at example and understand what I'm trying to tell you. Okay, the question reads, the length and width cover of a book measured to the nearest millimeter are 28.5 centimeter and 16.2 centimeter respectively. Find the absolute error in area. Let me repeat the question once again. The length and width cover of a book measured to the nearest millimeter are 28.5 centimeter and 16.2 centimeter. Find the absolute error in area. Now, that question is informing me something. Let me discuss on something out of the topic. There are things to do with 1x, 1y, 1z, 1a, and now we are having something like 1x plus 1z, 1y plus 1a. Have you ever seen such something in any working you've came across? I am sure no. But yes, in some students. You see, a good student of mathematics should not be writing one X, one Z, one Y, one A. Like, that one doesn't make sense for a student of mathematics. That one doesn't make sense. It's like that kind of someone is confused, just tired with mathematics, doesn't want to, I don't know how to term it. But having such things, they are really, I don't know how to term it. Now, there's a reason why I've told you that. There's a reason why I've told you that. If you look keenly at the question reads, the length and width cover of a book measured to the nearest millimeter. It can take a student who doesn't do revision so many minutes in an exam to terribly think on this question. Okay. And the question is just easy. Even though, okay, you see, kuna maswali zingine utafanya like ukuwe na bahati. Like for example, let me assume there's someone whom never understood this part. There's someone whom never understood to the nearest millimeter. Doesn't have idea at all. Doesn't have idea. Doesn't know what to do in that part. But now, yeye an idea and he comes. See, Francis taught me. He comes. Right there, actual, right there, maximum. Right there, minimum. And he has 28.5 and 16.2. Now, this student, considering 28.5, atapata nini? Atapata okay, this a number. So he or she will get the accuracy in that particular number. He or she will get the accuracy, and obviously the accuracy is 0.1. So he takes that 0.1 multiplied by what? Half, getting 0.05. Then you see him adding 28.55. On this side, 28.45. The same to 16.2, having the same accuracy, 0.1 multiplied by half, 0.05. On this side, having 16.25. On this other side, Yoshi will be having 16.15. Then, because it's find the absolute error in getting area, atakuja fanye nini? A multiply. Yoshi will come and multiply. So multiplying that in my calculator is giving me 463.9375. 28.5, that one is 461.7. 28.45, 16.105, that one is giving me 459.4675. Then because Yoshi knows that absolute error in combined numbers is given by maximum value 463.9375, then Yoshi will subtract to the minimum 459.4675, then divide by 2. Do you know, guys, that this student is lucky? 2.235. Huyu mwanafunzi ako na bahati kama ya mtende, because what the examiner has said and what Yoshi is doing is almost the same thing. It is almost the same thing. But I don't want you to take that direction. Ati wewe unafanya hesabu bila mpangilio. No. Do what you know. Like, if for example this number was this question was to be changed. You still have the idea. You see, having the concept, having the idea, it is different from knowing. There's a difference between understanding and knowing. You could know me, or I could know you, but you don't understand me, or I don't understand you. That is where now the issue or the problem begins. How I wish you people are really getting or understanding what I'm trying to say. How I wish. Now, this is not the right thing, even though the answer is right. The process is right. But the student has no idea at all, if whether what he or she is doing is right. To him or to her, whatever he or she is doing is right. That is according to him. But I tell you, this thing is wrong. Why? Because there are some things here the student doesn't pay attention to. That question was to be solved this way. Remember, the term nearest, just by its appearance there, that is not just a word. That is not just a word. It is more than a word. So there's a reason why I started by giving you some things to do with one Y, one Z, one A, one B. There's a reason why I gave you that, or I told you that. So this to the nearest millimeter is the same as to the nearest 1 millimeter. So there's no need for an examiner to write for you to the nearest 1 millimeter. It doesn't make sense. Like someone who will wonder, is this an examiner a teacher of mathematics really? Like 1 millimeter, how? Okay, in some cases it is allowed to have 1 millimeter, it is allowed, but now when it comes to other points, you sometimes have to think. You sometimes have to think. So this to the nearest millimeter is the same as having to the nearest millimeter. Yeah. Now, there is a formula here that some of you, I don't know, have the formula, but I always cram it. Not cram it, but memorized it in a some like wrapping manner, like kilometer, hectometer, decameter, meter, decimeter, centimeter, millimeter, and you're good to go. You don't have to master those, I don't know, king what, dag hole, what, moles. No. Just sit down, enjoy mathematics. Like you are reading, you're playing, you're rapping. All right. Okay. Yeah. So I always have a certain formula of wrapping. Kilometer, hectometer, decameter, meter, decimeter, centimeter, millimeter is very much okay. Like having something like kilometer, hectometer, decameter, meter, decimeter, centimeter, millimeter, and I'm done. We bado nataka kuimba that King Henry Dag Mold, don't know Diamond, what. Okay, but it's still right. It's still alright. Still alright. Now we are having millimeter and centimeter. So remember, it is to the nearest. The units of to the nearest normally differ or is not the same with the units of the other measurement. As in this case, the units of to the nearest is given in millimeter, and the units of the length and width are given in centimeter. So it is always recommended to convert the units of nearest to be the same units as the other given measurement. So that is what we want to do. So I'm having 1, then 0. So that one means what? That 1 centimeter is equivalent to 10 millimeter. What about What about 1 millimeter? 1 millimeter will be equal to what? Centimeter. So it is 1 times 1 divided by 10, giving us 0.1 centimeter. So this is our accuracy in the same unit as the given measurement. This is the accuracy. Okay, you see this nearest. It can be to the nearest 5, to the nearest 5 millimeter, to the nearest 10 millimeter. It will not always be only to the nearest 1 millimeter or to the nearest millimeter. And that is why I'm telling you that have the concept. Don't just know, have the concept. Understand. Understanding is better than knowing. Someone will like you because you understand him or her. Someone will befriend you because you are good in understanding. And that is why a good teacher of mathematics doesn't just cane students. Like, he or she understands. He doesn't know. He or she doesn't know. He or she understands. Okay, let us continue. So having now our nearest is in the same unit as the other given measurement. That is 28.5 and 16.2. So I told you that you only take this to the nearest. I told you to the nearest is the same as accuracy. So you only divide it by 2. Dividing it by 2, you get 0.05. 0.05. So this is the same thing. So if you follow the procedure, you will arrive to the same answer. So we have the actual, maximum, and minimum. So actual is 28.5, 16.2, 28.55, 16.25, 28.45, 16.15. Now, we can get the absolute error, but before that, we get the maximum. Now, here we were supposed to do what? Multiply. So upon multiplying 463.9375, 461.7, 459.4675. Absolute error will be given by 463.9375. That is the maximum minus the minimum. 459.4675 divided by 2, having our answer as what? 2.235. Now, the main reason why I'm telling you to understand, have the concept, is if, for example, if for instance, like 28.5 wasn't 28.5, rather it was 28.52, 28.52, then the other first student ambaye yeye anatumia like the word aelewi to the nearest angekwama hapa. Why? Because when the nearest is used, hata hizo numbers zishindane aje kwa in terms of decimal, like a number is being judged depending on the number of decimal it carries. Getting an accuracy in a number, it is being judged by the number of decimal places it carries. So this first student ambaye sasa angetumia 0.01 and 0.1 to get the maximum value of both numbers and the minimum values of both numbers, he or she will be doing the wrong thing, because when to the nearest is used, you see that kawada ndio utatumia mpaka umalize. Like for example, let me try to come up with a question, and I want you to listen. Let me just use the same. The length and width cover of a book measured to the nearest 5 millimeter. I've now changed it. The length and width cover of a book measured to the nearest 5 millimeter are 14.67 centimeter and 5.2 centimeter respectively. Oh, sorry. Remember this one, getting absolute error, our answer should be square units, not just 2.235. So correct on that. Now, what have I said? What have I said? The length and width curve of a book measured to the nearest 5 millimeter. To the nearest 5 millimeter are 14.67 and 5.2 centimeter respectively. Find the absolute error in the area. Find the absolute error in the area. So we'll come and have the actual, the maximum, and the minimum on this other side. So the actual, we shall have 14.67, 5.2. So you do not get the accuracy of these numbers. You do not get the accuracy of these numbers. You are not supposed to get the accuracy of these numbers. Listen. You are not supposed to get the accuracy of these numbers. Why? Because to the nearest thing has been provided. So that is what you use as your accuracy. That already accuracy has been provided. What does that mean? In some cases, you won't always be using the numbers to get the accuracy. Sometimes an examiner will give you the accuracy. And how will the examiner give you the accuracy? By the term nearest. Wewe ukisha tu ona nearest, it has appeared in any part of the question under approximation and errors. Know very well, that one is not just a number. That one is an accuracy. And that accuracy, you apply it in all the combined numbers. Right? What is our accuracy? 5 millimeter. So convert 5 millimeter to be the same unit as these other ones. You know very well that 1 centimeter equals to 10 millimeter. How about 5 millimeter? You take 5 millimeter, you multiply it by 1, divide by 10. So having 5 divided by 10 is giving us 0.5. So 0.5 what? Centimeter. So you take this 0.5, you divide it by 2 to get what? Absolute error. That one is 0.25. Now, it is this 0.25 that you will add to each and every number to get their maximum and to get their minimum. That is why I told that understand. Understanding is better than knowing. What is my what? My absolute error, 0.25. For a student who will not understand, like, let me use 14.67. 14.67 has an accuracy of 0.01. Then divide by 2, 0.01, then divide by 2, you get 0.05. So a student who may not have understood, yeye atatumia, like Yoshi will be using the accuracy of the given numbers, and that one is wrong. That one is wrong, guys. So make sure you understand that to the nearest really carries some heavy mark in that question. And that is now where position ones are being produced. You are position 1, you are position 2, you are position 3. Using these things, So make sure you are among the position ones. Now, having the accuracy provided from the nearest, it is what we shall use in each and every number. We won't get the accuracy of the numbers again. Now 14.67 plus 0.25. So we add to get the maximum 14.92. 14.67 minus 0.25, that is 14.42. Remember, it is applied in all the numbers. 5.2 minus 0.25 is 4.95. 5.2 minus 0.25. Oh, sorry. That one should be the minimum, 4.95. So how about if it was addition 5.45? 5 point what? 45. Then from there, you now get their areas, you multiply. What I'm only trying to let you understand that be very careful. E to the nearest. E to the nearest thing. This thing to the nearest will really mess you a lot. So make sure you understand it better. So when we meet next, we shall cover our concept number 3. And remember, we haven't tackled any question to do with the maximum or greatest error. And I want you to follow. I want you to be there. Remember, I told you that first I'm finishing up the topic, then we shall do the revision. Now, concept number 3 which we shall look in our next class is a use of inequality sign. We shall look on this next when we meet. I thank you for being with me until the end of the lesson. I hope you've learned something. So thank you, and subscribe if you haven't subscribed, share with others, and let us share knowledge together. Thank you once again.